我 send 那个 link 去给所有人先。好，来，我们开始了。为什么讲华语的？无所谓，都 OK 了，反正是 extra class。Alright, we quickly go through the revision on this chapter, chapter 4. Very quickly. Probably. So first one, 4.1, we talk about thermal equilibrium. Normally this one will ask in format question, right? So you need to know how to answer. Right? Later we are going to go and see some question. Right? So the keyword here is net heat flow equal to 0. Right? So other you go and 填充 fill in the blank. Alright. So the application, now you need to know some, right? It might give you some mark also, alright? So the calculation in calibration of the thermometer, it is theta is, if you remember the formula, L theta minus L0 over L100 minus L0 times 100. If you forgot about the formula, you remember the way that I taught you how to do, you can do it also, right? Now, 4.2, what do you need to do is heat capacity, alright? So, if got specific, then you put in 1 kg. No specific, no need. So, formula Q is equal to mc theta. C is equal to Q over m and theta. Q is heat energy. M is mass. Theta is temperature, change in the temperature. So you can say, what is C? C is energy needed for an object. If specific, you put in 1 kg. No specific, no need. 1 kg to change the temperature of an object by 1 degree Celsius. Alright. So what is the use in specific heat capacity in daily life? Heat capacity, high one, something like water, it used to absorb absorb heat. Right? For example, the car radiator, you add in water to absorb the heat from the car. Okay. Now, some of the heat capacity low one, it is easy to heat up. All right. High heat capacity, hard to heat up. All right. All right. So we got an experiment. All right. But experiment of heat capacity. In this heat capacity experiment, you need to know how to do it, right? Because of PT. PT is equal to mc theta. All right, mc theta. This is a power, right? Time. Power time is your energy is mc theta. So when you do the experiment, right, make sure you know what is the power and time. Time must in second. All right. So, and then that is some natural phenomena happen in daily life about the heat capacity. For example, sea breeze and land breeze. All right. So, at night time, all right, here it is cold, right? Cold. Here remain hot. Because no sunlight, heat capacity of water is high. So first of all, this one normally come out in format, heat capacity of water, it is high. So surface here heat up, hot air go up. Hot air go up, so pressure here getting lesser. Pressure at the surface of the sea less, right? So the wind blow from the land. Alright, wind from land, so it is called land breeze. Sea breeze also the same, right? The other way around. Alright, I don't want to repeat. Okay, now after that 4.3, what do we do is latent heat. Latent heat. Latent heat of fusion and latent heat of vaporization. Alright, so the most important thing is it heat absorb. Alright, latent heat here and here. This is fusion. This is vaporization. Alright, so energy needed, Q is equal to ml, the formula ml, right? Energy needed for 1 kg of substance is specific, then you can set 1 kg. 1 kg of substance to change the physical state without change in the temperature, right? If you know it is fusion, you set solid to liquid or liquid to solid. If you don't know, leave it, right? So if it's at release heat, it is something like that. All right, so this is vaporization, this is fusion. In another term in chemistry, it is the energy used to break the bond, right? Not to increase the kinetic energy. Sometimes they'll ask in physics also, so you need to answer here. Why the temperature not increasing? Because kinetic energy not increasing, right? Because the energy used up to break the bond, right? To overcome the forces between the particle, right? So this is about the latent heat, all right? And then normally they ask you a question from what state to what state. Let's say negative 10 to 100. So you need to break it into few stages to do it, all right? So I ask you, you have to draw it from solid, all right, to the melting point of solid, negative 10 to 0 degrees Celsius to liquid, 0 degrees Celsius to 100 degrees Celsius. All right, so you see the state change or no change here? No change, right? This one change, temperature no change. This one no change, temperature change. All right, so you level it Q1, Q2, Q3, and then do it. This one change, this one no change, right? So one state change, the other one no change. So you calculate Q1, Q2, Q3. When the temperature no change, you use ml. When the temperature change, you use mc theta. That's all. Lastly, 4.4, it is gas law. Gas law, I baru finished teaching this week, alright, including the experiment. I hope you understand it well. And then the only one thing that I ask you to memorize in PV over T, including the formula, including that one, right? So for those who just that one, because here got some from 5.1, so I go in detail a little bit. So P is Boyle's law, alright? Boyle's law said that pressure is inversely proportional to volume provided temperature keep constant, right? Charles' law said that volume is directly proportional to absolute temperature provided temperature keep constant. And then pressure law, oh sorry, not pressure law, Gay-Lussac law said that pressure is directly proportional to absolute temperature provided volume keep constant. And then the graph, then you got to memorize. And I want you to memorize one thing only. If PV over T here, so I don't care what is this, I don't care. So if this one got PV over T, all here it is constant, right? Either directly or inversely or whatever you go on your own. Okay, so that's 10 minutes revision for this one. So we are going to go to some exercise that I prepared for you. If we can finish earlier, then I will show you other stat paper last year, right? Wait. My brother from Japan keep on calling me. I don't know what happened. Give me 1 minute. Here. Okay. No. All right. The question right here. So this is the question I make to you. So we are going to do it. I see so little people do it only. All right. But never mind. Anyhow, we still need to do it. So now diagram below shows the two identical object A and B which is in thermal contact. The initial temperature of A and B is 60 and 20. Here it is A, it is 60, B, it is 20. All right. So which statement is correct about thermal equilibrium when it is achieved thermal equilibrium? All right. So temperature A and B, it is the same? No. Right? When thermal equilibrium achieved, their temperature, it is the same. Now temperature A higher than B or B higher than A, right? Both are wrong, right? I typing error. This one should be B higher than A. Okay, but never mind. Both are wrong. Net heat rate of heat flow from A to B is not zero. No. So it is equal to zero. You remember this one, right? It is answer, it is D. Okay, answer, it is D. D. Answer is D, yeah? Right, so we look at the second question. Diagram below shows the two identical object A and B which is in thermal contact. Thermal contact means they touch, haven't thermal equilibrium yet. Right? The initial temperature of A and B, sorry, I cannot move. Oh, E. Okay. Joey Sim ordered a cup of hot coffee in kopitiam. The hot coffee, it is served with the saucer. This is called saucer. Alright. Which of the following statement explain the function of the saucer? The waiter can carry cup easily. It is used to carry cup easily, or the coffee can reach thermal equilibrium easily, or to prevent the coffee to reach thermal equilibrium easily, or can drink faster. What does that mean? This one is hot. Here it is hot. Now if you put it directly onto the table, so the the what's that called? The hot cup will have directly contact to the table. So when directly contact to the table, the heat will lost to the table, right? Or the heat will transfer to table, the table will transfer some heat to the cup also until they reach thermal equilibrium. So the hot drink will get cool down very easily. So with this one must be saucer, must be insulator. Insulator, it is to prevent, right? See, to prevent the coffee to reach thermal equilibrium easily. Alright, that's the answer. Is that okay? Susan is drinking her lovely chicken soup. She pressed a spoon into the bowl of the soup at 95 degrees Celsius. Which statement it is correct about the thermal equilibrium when it is achieved? Right? When thermal equilibrium achieved, you need to see one thing. Right? There is no net heat flow between two objects, or it has a same temperature. So the temperature unchanged, this one unchanged. This one is keyword has the same temperature, or there is no net heat flow. Right? Soup and the spoon has the same temperature. Right? Thermal equilibrium. No net heat flow. Alright. Jolene, it is pouring the soup into the bowl. Which statement is correct? Alright. So the net heat flow from the hot soup to the bowl, or net heat flow from the bowl to the soup, or net heat flow only from the hot soup to the bowl, or net heat flow is 0. Right? Alright. So you pour the soup into the bowl. Right? So the soup normally it is hot, right? So the bowl normally it is cold. So when you pour it into it, so they will reach thermal equilibrium. Alright. Now at first, when you pour it in. Now this question, when you pour it in, this is hot. So the hot thing you will flow heat to here. Alright, flow to the bowl. The soup will flow heat to the bowl. But the bowl will also flow some heat to the soup. But this one is slow. This one is fast. Until they reach thermal equilibrium. When they reach thermal equilibrium, the net heat flow it is equal to 0. But before the thermal equilibrium, the heat flow from the soup only wrong, because it is both sides. You flow in and flow out. Heat flow from the bowl to the soup also wrong. Right? Heat only flow from hot soup to the bowl. No. Right? If you say net heat, okay. Right? Still got chance. Right? So net heat flow from the soup to the bowl still got chance. But after when this one is pour, answer is this one. But after a while, then thermal equilibrium achieved, then answer will be this one. So this one not mentioned after a while. So when you pour, so the net heat flow should be, the net heat flow should be flow from the hot soup to the bowl. Net heat flow. Okay? So answer is A. And when you pour, the hot soup is hot. So you flow some heat to that one, right? To the bowl. Right, next. Ethan is having a high fever, and then he used cold towel to put on his forehead. Because why? Heat flow faster from the towel to the forehead, and heat flow faster from the forehead to the towel. Right? So why? This is your head. This is your head. This is a wet towel. Red towel. So this one is cold. Your body is hot. So the heat flow up, it is fast. The heat flow from the towel to your body, it is slow. This is slow. This is fast. Right? So I said heat flow faster from the towel to the forehead, terbalik. Heat flow faster from the forehead to the towel, so that it can reduce your temperature. Answer it is B. Right? Answer it is B. Is that okay? Number 6. Mercury is used in the liquid in the glass thermometer. Which of the following is wrong? Alright. Now, mercury used because of few reasons, right? It has high melting point and low boiling point. Yes. Alright. It is opaque. Yes. It expands uniformly when heated. Yes. It is good heat conductor. Yes. But which one it is wrong? Right? Which one it is not the reason that we use? Right? Seems like all of them are correct. Which statement it is wrong? Which one is wrong? What do you think? Right? It has high melting point and low boiling point. Low boiling point. This one seems like correct, right? But actually it is wrong. It is high melting point and high boiling point. It should be, this one is wrong. Why? A, it is wrong. Why? It should be the ballet. It should be low melting point and high boiling point. Alright, baru correct. So answer it is A. Now I explain to you why. This is a thermometer. The thermometer, I want it to be in liquid form. Liquid form, So let's say, I don't know what is the melting point for the mercury. Let's say I put it as -100. It start to melt. Melting point. And then boiling point. Boiling point, I take it as 300, let's say. Boiling point. Boiling point, Okay, now this one, before you melt, it is solid. After you melt, it is called liquid. Then liquid, if liquid, this one is liquid, then it can expand. Right? This one can expand. So I want it to be in liquid. Right? So if it is after boil, it will become gas. Right? So if I use something that melting point, it is very low, mean it melt, it is liquid already. So liquid, then it can expand, go up and go down, right? This one can expand. This one will expand. This one can expand easily when it is in liquid form, right? Right, boil, then your boiling point is high. When boiling point it is high, meaning that it is not easy to turn to gas. So it stay in liquid. Now let's say I use other, alright? The boiling point is 25 degrees Celsius. The melting point, I'm sorry. 25 melting point. So the boiling point, I put it as at T. What does that mean? Right? So before 25 it is solid. So now I go and test 15 degrees Celsius, it turns ice. It turns solid. Then it will not move already. Cannot move. And after 25 it melt, then it can move. Alright, it can move. But after I want to test something that 90 degrees Celsius here, with using thermometer, tidak boleh. It will change to gas. It will evaporate here. So you see it has high melting point, no. High melting point and low boiling point, no. It should be low melting point and high boiling point, right? So other is all correct except A. Okay, I hope you can follow. Now the sensitivity of the liquid in glass thermometer can be increased by make it longer, the stem, make wider. So you want to make it more sensitive, the thermometer right now. You want to make it more sensitive, this one, right? Mean it can go up or go down easily, right? So you make this one wider. How can it be? Can make it this one wider? Impossible, right? Impossible. You have to make it thinner, right? And then use a thicker glass at the stem. That one is reduce the heat loss. Use a thin glass at the bulb. Yes, right. This is the best one. Why? The bulb here, it is used to absorb heat. So if you use something very thin, then it can absorb heat very fast. But the stem have to be thick. This part have to be thick. Why? I don't want the heat loss. This part, right? This part, when this one go up, expand, so I don't want the heat loss to surrounding. So this part have to be thick. But this part, the bulb have to be thin, so that it can absorb heat. The heat will go in from the bulb here. Will go in from the bulb. So answer it is D. Okay. Calculate the temperature of the warm liquid in glass thermometer with 4 cm pressed into the ice cube and 29 cm show when it is in the boiling point. Boiling water, it is 100 degrees Celsius here. This one is 100 degrees Celsius. Okay, now 14 cm when it is in warm liquid. Warm liquid lah. Right? warm liquid, this one, right? Now how to do it, as I told you, right? If you want to use the formula, right? Because now you are in yearly exam, so I use the formula, right? Theta will be L theta length when 14, length when 14, length when 14, minus length when 0, right? When you put into the 4 cm in the ice cube, 4 cm minus 4 over length when 100, 29. 29 is boiling water, right? 29 minus 4 times 100, which is you got 15 here. This is 25. 25 and 15 divided by 15 divided 25 times 100. So what you get? 15 divided by 25 times 100. What will you get? You will get it as 60 degrees Celsius. Answer, it is B. Okay. I hope you're okay. Now, next one, number 9. Thermocouple is used to determine the temperature of the drink. When 2 ends is placed into the ice cube of boiling water, 15 milliampere of the current flow into the thermocouple. But when 2 ends is placed into the ice cube and the drink, the current flow through the thermocouple, it is at. Find the temperature of the drink. Now, this one you cannot use the formula already. So I got 2 drinks here, which is here I got 2 N put into the ice. This is 0 degrees Celsius. This is 100 degrees Celsius, right? Ice cube and boiling water. Then you find it, these two N you put into here, the current will show you 15 milliampere. Now when 2N is placed into the ice cube and drink, right? Ice cube here is 0 degrees Celsius, right? We know. And then drink, I don't know. Theta, I don't know. But it show me some reading also. It show me it is at milliampere, right? So the heat flow to here and here, it is lesser. The heat flow to here it is faster, right? So 0 to 100 is 100 degrees Celsius. It give me 15 milliampere. I use ratio to do it. 0 to theta is theta. Theta will give me at milliampere only. So what I do is I cross multiplied it. I cross multiplied it, I'll get 15 times theta is equals to 8 times 100. So theta will be equivalent to 800 divided by 15. 800 divided by 15. So I get 53.3 degrees Celsius. I hope you're okay with here. And number 10. When the thermometer is placed into the ice cube, the length show it is 6 cm. Alright. So when you put into ice cube here, it is 6 cm. The thermometer put into the boiling water, the length it is 16. This is 6 cm. Here you put into the boiling water, it is 100. Here it is 16 cm. So find the reading of the temperature with the 15, right? 15. So you want to find this one here. It is 15 degrees Celsius, right? But how long it is L, I don't know, right? L, I don't know. So you can choose to use the formula. Theta will be equivalent to L theta L15, right, minus L0, right, L0 over L100 minus L0 times 100. You can use the formula. Now theta, it is 15. L15, L length when 15, I don't know. I put it as L. Minus L0, which is 6 cm. L100, it is 16. Minus 6 times 100. 16 minus 6, it is 10. 10 times 15, 150. 150 divided by 100. 150 divided by 100, 1.5. 1.5 is equal to L minus 6. This one come to here, become plus. 1.5 plus 6. It is 7.5 cm. Answer is A. Can you follow? Alright, I have finished this one already. Okay. Now, any question from here before we continue? Many of you not doing it. Right. Okay. So we are going to try to do some question from here, right? Okay. So we take one question from the MRSM trial, right? If not enough, later I'll take one more, right? Because I put in too much. Eh? The answer is question X is 40 degrees Celsius. Wait. Number 8. Wait. Number 8. Number 8. If not in second, it is 60. I redo. Calculate the temperature of warm water if the glass thermometer shows a 4 cm. In ice, alright, ice is 4 cm, 0 degrees Celsius. And then 29 cm when it is boiling water. 29 cm in boiling water 100. And then when 14 cm, I didn't do this one. 我有做吗? I skip this one 噶，好像一点印象都没有。我有做，好像我有印象是60的。So this one it is 14 cm. And then theta how much? Alright. Okay, I use ratio 啦。我以前60哈，我好像有印象是60哦。Right, 100 minus 0, it is 100. 100 theta is this one minus this one, right? 29 minus 4, it is 25 degrees Celsius. 25 cm. Now length is 14 minus 4, right? 14 minus 4, it is 10. It is equals to theta. I use ratio to do it. This one cross multiply, right? 25 theta is equals to 100 times 100 times 10. Theta is 20, 40. 40 baru betul. Where did I get wrong just now? Answer number 8 should be B. Should be B. Should be B, huh? B, 刚才我有算看，我算错哦。刚才我是用formula哈。Answer should be B, not D. B. Alright. Thank you for correcting me. Is there any other question? Is there any other question? Okay, we go for we go to structural question. This one actually I do for thermal equilibrium only, not for all. So other I haven't do yet. I pick up some thermal equilibrium to do. Right? What is mean by power? Alright, for Form 5 student, you will learn this one what is power. In Form 4 you haven't learned because you haven't learned what is electricity. But anyhow, when question come out, you also need to know how to answer. Right? No choice. Right? Number 10A. In Form 5 you will learn this formula. Work done is equal to power times time. Power is equal to work done divided by time. Right? Divided by time, we call it as rate. We call it rate. Right? Work done. Rate of work done. Rate of energy use. Unless they give you number. What is mean by 40 watt? What is mean by 70 watt? Alright. So this one you call it as. You are going to call it as rate of work done. That's all. Right? If they did mention about 50 watt, 1450 watt, like here, then you need to mention, right? You need to tell me. But here they don't, right? They sometimes they ask you what is that 1450 mean. You can say 1450 joule of energy used every 1 second. Okay. B. 10.2 show inside the A fryer. Right? Explain how hot air is generated and circulate inside the air fryer when the switch is turned on. Right? This one is 4 mark. How to answer? Give me an answer. Many of you here not doing. Give me your answer. Explain how the hot air is generated and circulate inside the air fryer. I will show you the answer later. The real answer. I haven't. Even I have done it. I have done it last year, but the answer I already forgot. Right. So, for Form 5 this one you need to score at least 2 mark. Right. Not at least 2 mark, right? Don't lower than 2 mark if you want to get A. If you get less than 2 mark, then it is kind of hard for you to get A. This one you get the mark. This one I want you to get 2 mark. At least 2 mark or above. Now you got 4 point, right? 4 point. How to get the mark? Yeah. 4 keyword. Alright. So we read the question inside here. Diagram 10.2 shows inside the air fryer. Right? Air fryer in Mandarin, you know, called what? Any one of you, your house use this? Air fryer. You renew吗？对呀，空气炸锅。对了啊，你不用油，你不用什么，你丢进去就可以炸了啊。OK。Explain how the hot air is generated inside the air fryer. 你想哪里会有？我哪里会有？我都没有用过。有用过啦，不是我用，我太太用。OK, so format here. So if you don't know how, then you have to talk about 你看这里可以帮你吗？这里有没有 power？ 有没有？你看这里 here, will they ask you about the heat? Will they ask you about the what? So you help you from here. If not, then You have to answer from you need to find something from here uh, to find the answer. All right. So now, first of all, any objection, any suggestion from here? How to fry the thing? I'll show you the answer later. Okay, come on. So we do it together lah, huh? I think if I wait for you, I need like 要等多1000年。Okay. Okay. How the hot air is generated? How the hot air is generated? The heater. Right. So the current here power current supply is converted to heat energy. Right. The power, electrical power, by the heater. Right? From 5 student, I want to ask you how the heater produce heat. You have learned it. How? From 5 student. How the heater produce heat? Huh? From now it is, if I talk about from 4, then how the heater produce it, they don't know. If from 5 you guys know. How? How? It is the resistivity of the conductor, the heating element must be high. When current flow through it, right, it release heat. It release light or heat energy there. Right? Can you understand what I'm saying here? I don't want to write that because this is not related. Okay? Now, converted to heat already, and then what happened? You have to talk about the fan. Talk about the fan, right? Because they ask you how is the hot air generated and circulate inside. So heat, the fan is used to circulate the hot air, right? The fan is blown, alright, blown, and then make the hot air go in, right? So after that, what happened? After that, what happened? After it go in, alright, so the food will be cooked, alright. For food will be cooked by the hot circulation of air. Hot circulation air, right? Right. So you see, I can only get 3 points, right? I cannot get even 4 points. So I go and get the answer for you, right? Here. Wait, give me 1 minute. Let me see. It is MRS. Wait. Here. MRSM trial 201 early. I show you the answer. MRSM. Alright. This is question number 10. I'll show you the answer. How do you answer the question? Probably I don't get mark. Alright. Okay. Now, I don't show you the next one. Right. state the definition correctly. All right. Power is amount of energy or rate of the energy or rate of work done. All right. This one, okay. Explain how the hot air is generated and circulated correctly. Now switch is on, the heat is generated by the heating element. Right? Right? Heat power is converted to heat energy by the heater. Right? When you turn on the power, when the switch is on, the heat is generated. Here will give you 1 mark here. This one will give you 1 mark. And then the radiant of the heat released by the heating element is high. I didn't mention. So I need to say heat release very high. Alright. Which is I don't have this mark. You see here? Don't have. Alright. The blower, the fan circulate the hot air. The fan is used to circulate the hot air. Okay, June. One more mark. The hot air is blown at all the direction. Right? Food will be cooked. Right? Result the food. Cooking the food quickly. Right? So let's say this one I don't want to give myself mark, so I will get 2 mark on it. Right? I want you to get 2 mark because you don't know. Hey teacher, how do I know you need to say the heat release is high, or I also don't know. Nobody know. They don't ask you the heat release have to be high or low. They never. So you need to predict on your own. So you have to put it into more word, more sentence, right? Especially in this kind of question, you have to answer in point form. Okay. Is there any question? Is there any question? You see, I get 2 to 3 mark only. I tell you, very good to get 2, very good already. Which is 1 more mark that I missed. It is probably it is the heat energy must be very high. Now, because of many of you haven't do it, right? So now here, I want to focus into this question. The answer is letter we got, right? I also want to do it. I want you to spend 10 minutes to do it, right? In C. If you haven't do it right now. Don't tell me you don't want to do and you don't want to like exam is soon, right? You always ask me, Cikgu can extra class, Cikgu can extra class. Ask you to do question, never do. Then how? You have to try to write. You don't write, you will never know how to write. So I'll guide you how to write, and then I give you some time, you do it, right? If you can, you not screenshot, you send it to me also can, right? If you do it, I want it to be simple, like something like you WhatsApp to me also okay, private to me okay, right? Let me see how do you do it. Characteristic, always like that, and then here reason. Now I help you. The air fryer, it is designed to fry the food without using oil. All right, so that is a few kind. So the power have to be how high or low. Answer me here, power high or low, and then you tell me the reason. And material should be heater. Heater should be iron or nickel. From 5-1, you know. From 4-1, sorry, no choice. It is related. So probably it is iron, probably it is nickel. I don't know yet. Later, then you know. From 5-1, you must know. Heating, melting point, it is high or low. High or low. And then why? Lastly, the electrical component, it is what? Thermistor ka? Thermostat ka? Why? This one you haven't learned. Haven't learned, then you have to tembak lor. No choice. Alright. I give you 10 minutes. We discuss after 11:30. 10 minutes to do it. That one, take the picture and send it to me. I go out, call my brother for a while because my brother called me twice. I make a phone call first, You gotta do it, please. Done it. 5 minutes. 5 more minutes. None of you sent. Mm. Shall I done it now so I can check for you. And who else? Who else has done it? Um, who else I check? From the Singru. Or you can submit also into the Google form if you want. Take the picture and send it to me if you have done it. Charlotte 啊，我要问你啊，如果我拿你的answer出来帮你改，你会介意吗？修在这里。OK，OK，Nicholas，不会哈，好，不会我就说，This is Charlotte's answer. OK， I'll mark for you and I will do it on my own later. 不是这个，这个，OK。This is Charlotte's answer All right, so we are going to discuss. All right, so high power of the air fryer, I think it is quite okay. Increase the temperature easily. Don't use temperature. Temperature is degree of hotness. So this temperature will not giving you the mark. So you can say heat up faster. So this one I will not mark. I will not give you the mark. Okay, I received some that one already. Wait Okay, this one I cannot give you the mark. Don't use the temperature. Use nichrome wire as material as heater. Quite okay. Yeah, quite okay. For me, quite okay. It is a good electrical conductor. This one is wrong. No choice. This one is from 5-1. For 5 students, they can do it better. Right? High melting point of the heater. Right? High melting point, okay. Quite okay. It is not melt easily. This one very good. Not melt easily. I like it. Use the thermostat as the electronic component. Okay. To help the control the temperature. Very good. I like this answer. I like this answer. Right? So X, I go and see. Yeah. X is 1005 nichrome, 1004 melting point. So thermostat, okay, X. So X is quite good. I like it also. And then repeat one more time. So you got 1, 2, 3, 4, 5, 6, 7, 8 mark out of 10 mark. Right? Is that okay? So I mark for you. I'll mark you 10 out of 8 out of 10. Okay. For me, I want to do it right now here. For me myself, I'll do it here. Right. First one, talk about the power, high power. No need to use so hard word. Simple word will be okay. Alright. As long as the keyword is matched, then okay already. High power, big power. Alright. Why? Right. So produce more heat supply. Heat up faster. Right. Or supply more heat. Can heat up faster. Second one, alright, for me, the material heater, it is using nichrome wire. Right. Now, first of all, when you choose this one and this one, you circle two of them, which is higher one. And then this one, if you are not sure, then you go for other. These two, right? High melting point, alright. I have to choose 4 of them. Right. If I choose 1500, then cannot already. Right. And then thermostat. Alright. This is what I want. Yeah. So this one is the best one. So I got the idea already. So I need to choose nichrome. Form 5, student. Why are you using nichrome wire? Right? Because nichrome has high resistivity, right? And can produce more heat. High resistivity so that it can give up more heat. Right? High resistivity, yeah. And then melting point. Now, you fried something maximum 200, 300. I want to ask you, if just now you insist want to go for, or teacher, I want the highest one, or I want to choose iron, then GG already, you will get something wrong. Because your air fryer here, the thing that you cook, probably it is 200 and 300 only. So it will not reaching 1400. Don't tell me 1400 it is low. Teacher, 1500 high, right? 1400 low. But this one power a bit, it can increase a lot, right? You more 500 and 1300 1500 got 200 watt difference, so it will produce more heat, different story. But this one, you will not reach there. You maximum reach 200 or 300. Normally, you cook the fish, you go your oven and see, fish 200, 180 only. You will not reach 1000, right? So still high. Don't say low, right? So the melting point, high melting point. Why high melting point? Not melt easily, right? The what not melt easily? The air fryer not melt easily, right? I just put in the keyword, right? Electronic component, right, that you use is thermostat, right? Thermostat. Why? Thermostat is something like thermostat is something like you can increase or decrease the resistance. Another word, you can increase or decrease the current. Or another word, you can increase or decrease the temperature. All right, you can adjust the temperature. All right, so the temperature, the temperature, the speed of the cooking speed, cooking speed can be adjusted, right, according to the way that you want. Right? You want it to be fast, then fast. You want 慢工出细货，慢慢煮，慢慢 so okay. Alright. So the best one, it is the X. Alright, repeat one more time. So this one, because high power, the power is high, and then power is high, and then nicron is used, and then high melting point, and then thermostat is used. Okay, so I got this few. Right, this is my answer, not necessary to be correct. So I want to check the answer right now. Okay, now I go and check the answer. Right, you see how do they give the mark? Right. Yeah. I want to show you how do they give you the mark. All right. So if I said power high power 1 mark, right? To produce more electrical energy per second, release more heat, heat up faster. They are the same thing, but don't use the temperature. You use the temperature, you won't get a mark, right? Nichrome wire, all right, nichrome, okay, not bad. High resistance, all right, high resistivity, more produce more heat, high melting point, okay, same, high resistivity, right? And then high melting point, right? Yeah, mama. Withstand high temperature, not melt easily, not easy to melt. Okay, withstand high temperature also can. Right, you can use the word, always use withstand high temperature or not melt easily. Right, thermostat can control. Right, can control. Right, because 我看到Charlotte 的 answer， 我不要跟他写一样的本来我也是想要写 control 的cooking speed can be adjusted. Alright, let's say, alright, you think this one not good. Alright, for me, I mark myself wrong. Alright, but to be honest, it is okay. Cooking speed can be adjusted. The heat can be controlled. Mean you can heat up fast, you can heat up slow. So I mark myself wrong, doesn't matter. Right? Now, lastly, it is X. X is the best one. And then tell me for one more time. State all the aspect characteristic of the table above correctly. One more mark. Right? So you can get this one easily. For me, it is 9 mark. So if you see Shelley, this is from 4, she don't know how to answer even, but she can get how many marks she can get? 刚才几分了？几分了啊？at 6 mark. No, at mark, at mark. You see how to answer. The technique of answering is very, very important. If you don't know how to answer, then you won't get mark. So if you know how to choose already, so you choose the right one, at least 6 mark. At least 6 mark already. Okay, can you understand? Yeah, are you okay with here? 我看一下这个哈。I look at this one. Power high. Alright, why? Provide high electrical energy, correct, 2 mark. Material heater is nichrome, stable at high temperature, you get 1 mark only. I don't want high temperature. Alright. Melting point, high melting point, yes. No, not melt easily, okay, 2 mark. The electronic component thermostat, alright, prevent the heat loss to surrounding, 1 mark only. This one no mark. Right? But at least you got a good try lah, right? And then it has high power. You repeat. So this one you get at mark also. Right? You get at mark also. Are you okay with here? Any question before I continue? I don't want to screenshot this one to you. Right? So I continue from here. See. Okay. This is Negeri Sembilan trial question. All right, so we try to have a look at this one. So what is mean by specific latent heat of vaporization? All right, number 9A. What is mean by specific latent heat of vaporization? All right, Q is equal to ml. Right, specific mean you have to put 1 kg energy needed for 1 kg of substance to change the physical state from, right? Because they said vaporization, you have to say liquid to gas or gas to liquid. You don't know which one, right? From gas to liquid or liquid to gas without change in the temperature. This is how you get 1 mark definition. Right? If you cannot, then you have to memorize. If you can, you use your own understanding to answer. To be honest, I tell you, the 4 mark question is the question that I hate the most because I cannot get 4 mark normally. And it is hard. They don't give you guideline like table just now. You can do whatever that you can, right? They will give you some guideline. This one don't have. Then you want me to get a mark? Not easy. So I say I don't want to force you. I give 2 mark only. And you want 2 mark, not bad already. 就很好了，拿到2分就很不错了。说真的，你们真的很多时候拿2分都很不错了，拿2分也能够拿 A 的。不要讲要拿 full mark 才拿 A Okay. Now, based on the physics concept, explain how cooking using steam is faster than boiling. Cooking with steam is. So when I don't know, then I'll come to here. You will give me some idea on doing it, how to do it. It is specific latent heat. At least I know it is something to do with heat or latent heat. Okay. Now, first of all, format. Any idea from here? Latent heat of vaporization is higher. The value of latent heat of vaporization is higher than specific capacity. Right, this one probably will give me 1 mark, but I haven't checked yet. All right. Now, second one, you want to cook the fish. Why it is faster? Right, steaming it is faster. So higher, so energy bring from the latent heat is more than the energy bring from the heat capacity, right? Steaming. Energy bring from the latent heat of steam is more than the energy bring from the I said don't bring absorbed by the fish. It's more than the energy absorbed from by the fish from the specific capacity. Right, this one can probably give me another mark. All right, and then what happened? So when the fish, now here there is a lot of steam coming up. When it hit, all right. So the latent heat of the steam, it is going to hit the fish. When hit the fish, then the fish will absorb the heat, right? Absorb the heat. When it go up, this one, the particle go up already. Let's say, yeah, how to, okay, go up. It bring a lot of energy. Then it hit the surface of the fish. Then what happened? Then it will reach the fish will absorb the fish. The fish will absorb the fish. The heat will absorb by the fish, and then this one become condensed. All right. So the steam from the steam will hit the surface of the fish and transfer the energy to the fish, right? And the steam will be turned to liquid again. All right. You see, maximum I get 2. So the one that I can get from here. Now I want to see the answer. All right. What is this? Negri MPSM. I go and search for MPSM. MPSM answer. Question number what? Question number 9. Yeah, question number 9. No name. Which question? Question number 9. MPSM. MPSM correct ba? Question number E. E, salah. I double check. Oh, got 2 set. MPSM. Okay. MPSM. This is not answer. Kertas 2 MPSM. Kertas 2 answer. This is answer number 9. Alright, I double check for you. Not double check, we check the answer. Here. No. Okay, now see here. This one is in BM lah, no choice lah, huh? Okay, now the first one that what we have is steam bersentuh dengan ikan, right? Steam, no right? The heat energy absorbed by the fish from the latent heat is more than the blah 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 blah. The hint stick, ini bersentuh dengan ikan, yes, right? Haba dipindah dari steam ke ikan, right? And transfer, okay. Now sometime in this one, right, you see heat transfer from steam to fish, heat transfer from to fish, right? But I put in one sentence, so when marker they mark, they cannot locate your answer. So when they read, don't have tick this one, okay, finish. So this one, me myself, you see, just now I thought this one is a point, this one is a point, so this one is just follow, right? Just use to support this one. So I don't think it is a point, so I put them separately. But in fact, real technical answering is you don't put them together. Put them together, you're short of that mark. If you put separately, then you definitely get 1 mark. Steam, the condense become water, and the steam will turn to liquid. 3 mark here. And then I do it separately, and these 3 mark all together, I get 1 mark. Technical answering. This one is I will tell you in my seminar. All right, this is technical answering, right? And then the heat is transfer, right? This is haba pendam tentu penguapan yang besar dipindah dari steam ke ikan, right? No more. So you can get 2 mark or 3 mark very good already in this case, right? Mean the last mark is the heat, the big latent heat of vaporization is transferred from the steam to the fish. 1 more mark. Is that okay for you? Question? I hope you're okay. Next one. All right. The diagram shows the job, all right, the refrigerator with the real view of the refrigerator. All right. So now you are asked to investigate. You are asked to study the specification of the 4 cooling system refrigerator. Determining the most suitable cooling system need to be used for the purpose of removing heat from the food. Justify your answer. Justify your answer. Justify your answer. Okay. Now, table, same thing. We are going to do it together. Can you help me? We do it all together. Here, characteristics, reason. Okay. Now, first of all, the material of the pipe, steel or copper or aluminum or copper. And then second one, uh, heat capacity. Heat capacity have to be high or low. Third one, the boiling point of the coolant, small or big. So this 这个就是你的突破口了。So 你一定要选这个。If this one you don't know, this one you don't know, and then you have to choose this one and this one. Right? These two don't know, then don't do this question. Don't do this question. Right? Okay, now help me. Do you think boiling point of the coolant have to be high or low? Boiling point. High or low? What do you think? Come on. What do you think? High or low? Now, boiling point, high or low? Then lastly, okay, if you still don't know, condenser coil must be which, what shape? It is turn. Alright, have the big surface area or small surface area. Big surface area, huh? Left this one and this one. Alright, I got these two already. So now, for this one, 难哦，这一个我自己都不会，我做过了，但是我忘记了啊，去年的。哦，我没有看答案，做问题我没有看答案给你们的。The boiling point of the coolant. Boiling point of the coolant. Now I got copper already, so I only can choose copper for this case, the pipe. Alright, so the heat capacity. So from here, this one is high, right? So I said the heat capacity must be low already. Right? Then left the last one. Right? For me, the boiling point. Normally it is gas or CFC it is gas or for me I think it is small. Never mind, I choose this one. I said it is small. Alright. So you see whether correct or not later I want to mark on my own. Alright. So copper. Alright, the material of the pipe are copper pipe. Stronger, not if steel very hard. Steel very strong, but very hard to de-shape. Copper it is soft, but you see your aircon all use copper, right? So easy to de-shape for me. Right, you can change the shape easily. You can bend it. You can what? You can put longer or what? And strong, not break easily. Right? Not break easily. Alright, you can write few. Right? If you're not sure, you write few, but don't write full lah. You don't write 全部什么乱写，strong not strong, not break easily 啊，你写你认为可以的就可以了。Okay, copper pipe. Second one, heat capacity, low heat capacity. Don't copy ah. Later I'll show you the answer. Low heat capacity. Why low heat capacity? When high heat capacity, it can absorb a lot of heat, right? So because of this one, I want it to change, evaporate, and then change to wait high low heat capacity. Low heat capacity it will not easily 是咯，我想要选 big 哦。你看现在我又没好选了。 如果这里我要选小 hit capacity 400 only. I come back to do this one later, and then the boiling point of the cooler, right? Low boiling point. For here, I have to choose low boiling point, right? Low boiling point. Low boiling point. Why low boiling point? 我也是觉得哦，如果我选这个就 aluminium 了哦 ，aluminium 大，这个又小。Low boiling point. Low boiling point. So it will change to gas easily, evaporate easily. Evaporate easily. Lastly, large condenser coil. Larger area of condenser coil. Right, why? Can distribute the heat out easily. Right? Can throw away the heat easily. So the best one it is K. And then repeat. Right? This is what we have. Low heat capacity. Now I don't know how to do. I just simply say it will turn to gas easily. No, 不是嘞。Should be high heat capacity or it can absorb. 哎呀，我又很想改韩色。It can absorb heat, more heat, if high heat capacity. 这个the coolant inside normally it is high heat capacity, so it can absorb a lot of heat. Then I have to choose aluminium. I change this one to high. I use my own answer. High heat capacity. Can absorb a lot of heat. Absorb more heat from the refrigerator. Yeah. High heat capacity 你可以吸很多。Low heat capacity 吸一点点，它就变成 gas 了。Then this one I have to choose high boiling point. High boiling point. It will not turn to gas. Not evaporate easily. Large area. Then I have to use aluminium here. Strong, not break easily. Right? The answer I choose now, I will change to L. 没有办法了。The thing that made me change my idea, it is this one only. Because no other than it is better. Right? So now I tell you this is how we do it. When you are not sure if I wrong, I tell you this one when I wrong, maximum the mark I can get is, I choose the wrong thing, maximum I can get it is 6 marks in the exam. So make sure when you got 2 choices, you make sure you choose the best one. 你不会写它的的 reason 也不要紧，就是选你会的那一个，你很 sure 的那一个。Okay? Okay, here. GG 了。 本来对的开了就气。哎呀，人生就是这样，大肠包小肠。OK，but never mind, good。我就喜欢啊，真实一点啊。Copper，copper, they choose copper. Wrong. Okay, wrong. This one no need to say already. This one wrong. Alright, heat capacity low. I choose heat capacity high. Alright, it can absorb heat. I thought, wait, I thought, wait, the heat capacity, not the coolant, not the coolant inside. Coolant must be high heat capacity. This one it is the coil, the heat capacity of the evaporate coil. Coil, not the coolant. I thought it is a coolant. I didn't read the question well. That's why I changed it to this one. If the coolant inside have to absorb heat, outside it is you release heat. That's why lah. You misunderstand, then everything is wrong. Okay, this one wrong already. High boiling point. Alright, this one, no need to say already. Alright, evaporate easily. This one get 0 mark. Alright, area bigger. Alright, yes, this one area bigger. Alright, can bebas haba cepat. Alright, can this easily. Alright, so how many mark? I get 2 mark. Because why? Because I choose something wrong. Like just now, you see, just now, if what I do is I use other color. Just now, if the one that I choose it is, even it is this one, it is wrong. This is copper. Copper, and then low heat capacity, and then low boiling point. Okay, and then I choose K, and then I repeat. You see how many marks I get? Even this one I explained wrongly, but this one I got mark 1 mark, 2 mark, 3 mark, 4 mark, 5 mark, and then 6 mark, 7 mark. You see? 1, 2, 3, 4, 5, 6, 7 mark. If I choose the right one only, I get 7 mark. This one, I consider all of these you don't know how to answer. This one, tidak pandai. Right? You don't know how to answer. You also can get 7 mark. Now choose the right one, correct one. When you are very sure, then you baru do. Because you got 2 choices in the exam. You understand what I'm saying here? Is that okay? I still got one more question want to give you as what? Okay. I want all of you to do here. This is Johor one. I want you to do here. Now don't say you don't know how to do, please. Alright. I also don't know how to do, but I want to try to do it. Alright. See. This is okay, I read 9.1 shows the employee of the bakery shop. It is busy baking the bread by using the industrial oven to meet. Right now, you see, this one, format one, is based on the equilibrium. Explain the flow of the heat occur in the bread. Hard or not? Hard, we don't do. I want to do this one. Now I want to do this one only. I want you to spend 5 to 10 minutes to help me to do this, and then mark on your own. We learn together how to get. The more that you do few times already, you know, oh, I need to do something like that. Help me. Try to do. I give you 10 minutes 啦，5分钟有一点勉强你了，说真的。10 minutes, okay? 10 minutes to do it. I read the question for you. Table show diagram 9.3 shows a food storage container carried by the food panda man by using motorcycle. All right, they put the food inside here. All right, the you got PQRS, right? This field, all right, PQRS, right? Which one is the best one, right? Specific heat capacity of food, right? And then the size of the food, the cover, the container, and then the material inside, and then lastly the outer material. Right, choose one. 10 minutes, we discuss. Be right back. Janet, no one sent to me. I do it within 5 minutes. So we discuss later. I do on my own. Send it to me. Inner material in the container. Aluminium. Outside, it is PVC plastic. The best one is P. And then repeat. High C. Big container. Big container. Big container. And then aluminum inside. And then PVC outside. High heat capacity container not heat up easily. I don't think so. Not a good idea. Because the heat capacity high, the container mean it will not go out easily. It will keep the thing that. Oh, I know what you mean. All right, what you mean is okay. What do you mean is under the sunlight it will not getting hot, right? So you want the food getting hot, so the thing is preserved, and then you are going to put the container inside the this stuff. 你的 food 是放在里面 then this is a container inside. It will not directly go under the sun. I guess what you mean is you takut the sunlight will make the food like no, no, the sunlight will not directly hit to inside. You understand? The container, this is container inside, then this is the outside material and inside material. Inside material and outside material is here. Outside is one more layer outside here. Inside here it is one more inside layer here. Do you understand what I'm saying here? Inside material of the container, or this container. Right? Okay. Aluminium, why? Now I compare to polystyrene and aluminium. So I'll choose the aluminium because I have to choose it. Right? If not, I'll got polystyrene. Maybe I will choose polystyrene. Polystyrene, if it's fall, right? Pecah, right? The thing gone. Alright. So this is stronger and not break easily. Right? And then plastic. Plastic PVC inside. So this is stronger than outside PVC, high heat capacity. If not, I got nothing to write already. This is my answer. Okay, this is my answer. So I want to go for the answer here. Wait. Question, what question? Johor. Okay. So we are going to see our answer. Some of you showed me already. Good. 学了，我可以收你的麦，学了，收哈 ，OK，OK, I mark for you, huh? I mark for you first, and then I mark for my own letter. Okay, so first of all, here, this is the answer. Heat capacity low. Oh, 惨了，惨了。Fast heat up, and then this one is big. Okay, this one, the thing that I mark myself first. This one wrong, right? Wrong. Then this one no need. Okay, this one is correct, and then this one is okay, and then this one is okay, and then this one is wrong. So this one big. Why big? You can see big can store more food, contain more in one go, right? Can put more food all together, right? And then the layer of aluminum is fast heat, right? Temperature rise fast, right? Stronger, not break easily, right? Good thermal. Okay, this one all wrong. And then heat capacity is poor heat conductor, safe to handle. Alright, I said poor heat conductor, alright, mean high heat capacity, poor heat conductor, right? But they don't use heat capacity, so I mark myself wrong also. Alright, so 1, 2, 3, 4 mark. 1, 2, 3, 4 mark only. OK， 好，我看你的哈，可能你的都会拿到比我高分。哪里了？Look at this. High heat capacity. Alright, most of you will say high heat capacity, including me. Alright, high heat capacity. Wrong. This one is wrong. 错了，这个错了就很难拿分了。OK, big container. OK, betul. Big container. Aluminum layer of this one. OK, PV plus 6, okay, this one wrong, right? This one wrong. So 1 2 3 4，看这里有没有分啊？this one wrong. The bigger size can increase in the temperature. 这个就不能了，不能给你分了。cannot get the mark. You will not break easily. For me, I think it is correct lah, but I mark myself wrong, then I mark you wrong, right? PVC, good insulator, very good. This one very good, good insulator. Yes, right. 1 2 3 4 5. 我的 1 2 3 4 only. Yours one is still higher mark than mine. So we go and discuss this one right now. Okay. Now the answer is low, right? Low heat capacity, so can heat up faster. So we go check what's wrong. Look at this. Okay. Here. Now low heat capacity, they want low heat capacity. This one big, no need to say, right? This one big. And then this one aluminum. This is PVC. Alright. So the thing that you wrong, it is I wrong, not you wrong. I wrong, it is I choose this one. Sorry, I choose the high one. So they want the low one. To be honest, not so logic like. Heat capacity of the food container must be low. Their answer, this is answer scheme. All the teacher they will mark according to the answer scheme. The heat capacity of food container, it is low. Why? Easy to heat up. Easy to heat up. Easy to heat up. Not logic at all. Okay, for me lah, I tell my on point. I will stick to my answer. I'll stick to my answer. Why? Because you are not going to cook it here. You cook it now. If you use to heat it up, you want to cook it from here, then you need it to heat up faster. But this one, I want to stay hot. I want it to stay hot because I probably need to send to a quite far place to make sure it is stay hot and then taste good. If cold, I order some clay pot mee, you send to me it is cold, then how can it be taste nice, right? So I think the answer is not so right, but anyhow, if I mark from the answer here, I got 1 2 3 4 mark. If I stick to my answer, I'll be 1 2 3 4 5 6 7 8 mark, and then these 2 mark probably I will not get it. Now do you understand how to do it? It is not so easy, but you have to choose the best one, right? For me, this question I'm quite confident it is this one, but anyhow, answer come up it is wrong. For me, 如果你给我多一次机会一模一样的问题，我还是选 heat capacity high，我还会选 P 因为I explained to you already why. I explained to you why it is not cooking. If cooking, then 我会选这个，它不是 cook。我去读了，你看他们讲是 cook if you are on the spot, you cook it, then the heat capacity have to be high so that you can cook it faster. Heat capacity low, sorry. Heat capacity low, you can cook it up faster. Now, any question from here? Any question from here? No question, then I want to do a bit of that one promotion. Promotion. I got a physics seminar and biology seminar with Madam Winifred on coming 5th and 6th November, and then tell you how to answer question. Tell you this kind of question. How are you going to answer? How are you going to score? Where do you get the mark? Alright, so I will do some forecast also, alright, the prediction also. So I will send you the detail in the group, and if can, alright, you can ask your friend to join also. If your friend join, I will give you some reward. I will 我会给你小一些小礼物啊，不是小礼物啦，会 return 一点钱给你。好，具体上是多少，到时候再跟你们讲。Ask your friend to join 5th or and 6th November, Saturday and Sunday. Some of you already have your mock already, but if you not, all right, you want to join also can. All right, if you are going to prepare for your mock, then that is the right time. Right, 那个是很好的时机，我会帮你们做一点 revision，然后教你们再怎样子去 score 这些问题。啊，biology 也是，然后我太太会教。Any other question that you want to ask me before I end the class? Any other question that you want to ask me before I end the class? Any question? Alright, if no question, then I am going to end here. I'll see you next